school.
My name is Cosx from primary 2, also from Urban Primary School.
This lesson is Calculus, Chapter 5, Indefinite Integral. Remember, for the indefinite integral, we're moving on to substitution.
Yes.
But remember, in substitution, we also can use quite a number of things that we used before, right?
Correct.
Well, first we can start off with those things that we learned before. After that, what I mean is this question, okay? After that, we can have some substitution, right?
Yes.
Okay, so for this question, we'll start with the first method. Can?
Can.
This first method,
And the question is integral dx over sine x plus cosine x.
so first for this, what do we have to have?
We have.
Can we denominator rationalization?
Yep.
Like this, is it right?
Yep.
Okay, well, for this, the sine x minus this cosine x. Remember, this is just rationalization. After that, for this denominator, we can also have those ones to be separate, okay?
Yep.
Okay, so right now for this, what can we get? Remember, for this sign, we put it in. It will have a,
Cosine.
so it's a cosine, right?
Yeah. And cosine put in negative sign.
But remember, here it is cosine, right? Cosine,
Yep.
but remember there's a negative, okay?
Yes.
So for this part, we can change the sine square x to those that have the cosine square x, right?
Yes.
What is that trigonal formula?
The trigonal formula.
Write it out. Write it out. Well, actually for this part, we can use the negative to switch these two places. Okay, can we have that later? Remember the sine square x plus cosine square x equals 1? That's when we use it. So right now, because here we have this sign, so we can change this cosine square x using this. Like this, am I right?
Of course.
Okay, so So we change these two places, right?
Yep.
Meanwhile, we also can separate them. Do you get what I mean?
Of course.
Am I right like this?
Yep.
Then we can have a partial fraction.
Yes.
So remember for this partial fraction, is this right?
Of course, correct.
Well, so it would actually be quite obvious that these will all be long, right?
These will all be long.
But
Yes.
remember, because we need to have this extra 1 over square root 2,
Yes. So we'll take it out and put one in.
actually all of these we can put in, right?
Yes, so that's why we need to take out.
Will this be a positive or a negative?
It will be positive.
Okay.
Opposite and again.
How about this?
It will be negative. Next will be positive of the opposite. After that is positive. Don't stick your tongue out.
Is this right?
Yes. Plus.
Plus what? I forgot. What is it?
A, B, C.
Like this. Right?
Yes. Arbitrary constant.
So for this part, can we denominator rationalization? Which is the denominator times the square root 2 cosine x minus 1 and the square root 2 sin x plus 1. Okay?
Not carbon.
But remember, this can be our answer because in indefinite integral we have many different answers and they can convert each other.
Yes.
Is it right?
You? Because it's a modulus, so we don't care. Is it a negative or is it a positive, right?
Too early.
Yes.
Okay, well for this, using the double angle.
And plus we can take down the 2. Which is the
Okay, let me just tell you, for this double angle, we can have first there's the double angle for the cosine, right?
Yes, and the double angle for the sine. Actually, not really. This one is still a cosine but a negative, and we ignore the negative. A square take out.
Like this. Okay, are you really sure about that?
Of course. We could even take out the square root too.
Wait.
Actually,
Change this into another thing. Well, this is why we get these two, okay?
yep.
Oh, in this case, you're going to use this, okay? So just to tell you that we get this because using also this one.
Like this.
After that, for this part, we can separate, right?
No.
Which is actually called the factorization.
Is the numerator or denominator?
Denominator.
Yes.
Excuse me. Cosine plus 1. So these two, they will cancel.
Yep. Now square root 2. What shall we do with this extra square root 2?
Can we put it on the outside? Well,
actually, it's a simplify.
well, factorize it's actually something like put it on the outside. Then because they're both the numerator and denominator have it, so you can simplify them.
But in that case, remember the plus 1 also need
Over the square root 2. Right, the 1. Okay, so you rationalize it, right?
Yep.
So like that, it is quite obvious that the square root 2 over 2, I can make the sine pi over 4 or cosine pi over 4.
Actually, until here is still the answer, right?
You can write it as the answer.
But then not the answer that we're finding.
Well, what do we, because we want all these methods, right? And all these methods, remember the indefinite integral, they all can convert into each other, these answers? So we'll convert this into the final answer, which all three methods should be getting. All three or more, right?
Until now, correct?
Yeah.
Remember anything?
Okay, it's the sine plus sine and then the cosine plus cosine, right?
Write it down the cosα.
So we use these two, right?
Yep.
Then plus a simplify.
And don't forget the last thing that we are going to do.
Hocus pocus, it become a tangent.
Yep.
Like that, is it right?
Yeah.
Wait, so for this part, what you can have is to separate these two.
Okay. I may do it here, Ken. Or here.
Like this, is it right?
Yes.
So for this, this is the first part, right? I remember
This
it's
question.
the first method, right? Well,
Yes.
we have more methods.
Yes, and summarize.
Okay, well for this method, you see we can have different things. We use different
Yes.
formulae, identity, right?
Yes, and from the steps, we got use the
Okay, so let me just tell you from this step we use the rationalization.
yes, then
Actually, this one separation, right?
yes, separation. After separation,
At the denominator we have the
remember
we
the
use the identity, right?
yes, the trigonal identity.
After that, at the numerator we put these in, right?
Yep. Then we will
Okay, then for this part,
factorize the denominator.
yes, we factorize the denominator,
With
partial fractions.
partial fraction. Yes.
Then you still remember the basic formulae, the one that is the integral 1 over x, then a dx.
Yes, which is a ln.
Yes.
And remember, minus is a divide, plus times.
Yeah.
And over here, which is
Okay, so after this we have the denominator. Can we call this a denominator rationalization?
yep.
After that we can use the double angle formula.
We'll use the double angle formula. Then we'll use the
Okay, say double angle formula, right?
yes. After that,
Factorize,
factorize. Next is
simplify.
yes. Simplify.
Okay, after that factorize and simplify, right? Because I will factorize the square root 2 and simplify them, right?
Yep. After that, we will change it into a sine or cosine.
Yes.
We'll put
Then
them
we use
together. We'll use the cosα method.
these two, right?
Which after that we simplify, we change it to tangent. Last but not least, we just separate these two parts, but we don't separate it into two tangents like just now.
Okay, so are you clear for this first method?
Yep.
Last time we used one method, right?
Yes, the method is denominator rationalization.
Which is mainly about the rationalization, right?
Yes, and last time we get the answer 1 over square root 2 ln modulus tangent bracket x over 2 plus pi over 8 bracket modulus plus c.
Well, not exactly because in indefinite integral we have many answers, and all these answers we can compare each other.
Yes, but last time mainly we
want to show that all these methods can get the same answer, which is actually, it means that all these methods are right.
Yep.
Okay, and remember here we have the sin x plus cosine x, right?
Yes, and this method will be trigonal identity. We will need to get the same answer as last time. At last. We also can have other answers, but mainly we'll only find when we found this.
Okay, so for this, what would we first have? Can we change the sine to a cosine?
Yes.
Which will be like this, right?
Correct.
Then after that for this is the sum of two trigonometric functions, right?
Yes. And we'll use the cosα-cosβ.
So these two plus like this, is it right?
Yes.
Okay, so like this 2 cosine pi over 4, then this cosine, right? Remember, cosine pi over 4 is?
Cosine pi over 4 is sine pi over 4, which is actually square root 2 over 2.
What happens when square root 2 over 2 times 2?
Square root 2 over 2 times 2 is still a square root 2.
Then we can have the numerator denominator times.
So it will be a numerator denominator times cosine. So both are cosine. Right? Right?
Wait, so for this numerator we have the cosine this thing, right?
Yeah.
So the denominator we have the square of this. Like this, is it right?
Yes.
Then we can put this in, right?
Correct.
But remember this cosine square, we can change it to?
We can change the cosine square to 1 minus sine square, which is actually another identity. So it will be like this.
Then what can we have?
We could.
Okay, so for that cosine square, can we put this negative in?
Yes.
So that these two will be the inverse order, right?
Correct.
And then we can use the a squared minus b squared.
The a squared minus b squared equals to a plus b bracket a minus b bracket.
So this 1 minus sine squared, this thing will become like this, right?
Yes.
So like this, until here, do you get it?
Correct.
So for this 1 over square root 2 here, we can
We
split,
can separate, okay.
okay?
Which are actually partial fraction.
Like this, is it right?
Yep.
Okay, so next, what do you think can we have? Can we
Yes.
integrate?
Next, we could integrate.
So for this part, this long, what's at the denominator, what is at the numerator?
The other denominator, which is
And remember, the plus is actually a times, or the minus is actually a divide. Well, this is only for this long, right?
yes.
Like this, is it right?
Yep.
Then what can we have?
We could have.
Okay, so at this part, 1 we can change it into. 1 we can change it into
Now we can change it into a
sine half pi.
sine half pi.
And remember, because of this modulus, so this order doesn't matter, right?
Yes.
Like this, is it right?
Yep.
So right now for this sine part, what can we use? Here we have the sum and the difference of two trigonometric function, right?
Yes. So we'll use two more things, which is still the circle, cosine, cosasa.
So for this, we'll have this part plus this part. Next is that this minus. Plus minus. Like this, is it right?
Yep.
So 2 and 2 can simplify. Can?
We can.
So for this cosine inside here, we can calculate. Wait, this part minus. Like this, right?
Yes.
Okay, so for this part, can we change the cosine? And can we change this sine?
Of course.
So for this, we of course change it to sine, right? But sine what? There's the problem. So we have the half pi minus this whole thing, right?
Yes.
So half pi minus that whole thing. Wait, isn't it the same as this?
Yep.
Square, right? How about this part? This will be a cosine, right? Half pi minus, right? Right?
Yes.
Okay, half pi minus this part. Same thing, isn't it?
It is.
Then square, take down, right?
Correct.
So he'll cancel, right? What's left? tangent, right?
Yeah.
Like this. Am I right? So is this correct?
Correct.
Okay, so these two methods are correct, right?
Yep.
Okay, so let's just see what have we used. So we changed this sign, right?
And plus our answer the same, so it's correct.
Yes, that's what I said. So here you change it, right? After that, you use the sum of two trigonometric functions, right? Which will get this, right?
Yeah.
So after that, you see inside here we actually use a lot of trigonometric identity, right?
Actually, here also can.
And remember, it is the sum and difference of trigonometric function. Plus is the sum, minus is the difference. Okay?
Yeah.
Okay, well, we can... Which part can we take as the answer? This part. We can take this part as the answer, okay?
Yep.
If we don't take this part, then we'll take this part, right?
Correct.
Okay, so are you clear so far?
Yes.
We have used two methods, right?
Yes.
The first method, which we mainly use rationalization, and the second method, which we mainly use the trigonal identity, right?
Yes, and method 1, we also got use a bit of trigonal identity plus as the rationalization is denominator rationalization.
Yes. And how about for method number 3?
It is trigonometric substitution.
Yes, correct.
We will need to let t be tangent x over 2.
So we use the tangent half angle, right?
Yes.
And what is the range for x?
The range for x is from negative pi to positive pi.
So this dx will be?
So dx will be
Like this, is it right?
yeah.
Okay, next, sine x. What could it be?
We will use the double angle formula.
For sine. And remember, the denominator is actually a 1. So we can change that 1. So we can change that 1 into like this. Is it right?
Yes.
Therefore this. Can we numerator and denominator divide by cosine square x over 2?
Yep.
So up here, this will be a, sine over cosine, which is a tangent, right?
Yes.
And this is a,
Tangent square x over 2.
like this, is it right?
Yes.
Correct?
Yeah.
Cosine, what would it be? We also use the double angle formula, but this one is for cosine. Wait, it's a cosine first, then sine, okay? Then after that we can, this denominator is 1, right?
Yes.
1, we're going to change it into the
sine square x plus cosine square x.
yes. Like this, is it right?
Yeah.
And then after that, can we denominator divided by cosine square x over 2?
Yes.
Like this, is it right?
Correct.
Okay, tangent square, this is a t, right?
Yep. So 1 minus t squared over 1 plus t squared.
So we have these already. Am I right?
So now I'm going to sub it in.
Sine is this part. Okay, actually this one is also the 1 plus t squared, right?
Correct.
These can cancel? Can? Like this, is it right?
Right.
So right now for this part, can we have a negative to change this order and completing square? Can we?
We can.
So we have this t squared minus the 2t, right? Obviously minus, and this 2 will be this 1, right?
Yeah.
So this will be a
Minus.
positive 1, right?
Yes, and
Positive 1, but at first we need a negative 1. So we'll minus 2. Am I right?
right.
So right now for this part, we can factorize. Can we?
We can.
Like this, correct? And do you know how to continue? Okay, next, we have the partial fraction.
Yes.
And remember, because these two parts, we need to cancel them. So
Yes, so we need to separate.
So we're just left with the 2 square root 2's, right?
Yes.
So here we're over 2 square root 2, 2 and 2 can cancel.
Correct.
Yes. Then after that, you can integrate.
Correct. Since still at the bottom because the negative here.
Good. Okay, here you actually need to put a C1. Put it a C1.
So now we are going to sub back.
Well, okay, yes, you can sub back. And also remember, the negative changes to places.
So now we are going to find what 1 minus...
And your arbitrary constant.
Now we are going to find what is 1 minus square
And
root.
don't forget to put the negative to reciprocal.
Okay.
Then the numerator. Then your arbitrary constant. What will we need to find?
What is square root 2 minus 1?
Why?
Because we don't know what is square root 2 minus 1.
And remember, we'll need to get this as our final answer, right?
Yes.
We must change it to something else. We cannot just leave it like that, although this can be the answer, right?
Yes. Actually, from here already can, but we just need to sub back. Then here the actual answer already, but we want another answer.
Like this, is it right?
Correct.
Then after that, when you combine one of these with this, what will happen?
It will be a
1.
1.
So it will be a 1. We'll be just left with this part, right?
Correct.
And this part, here we have this square root 2 minus 1 over square root 2 plus 1. Can we simplify as square root 2 from both the numerator and denominator?
Yeah.
Do you know what is 1 over square root 2?
1 over square root 2 is actually square root 2 over 2 with the sine or cosine pi over 4.
So it's like this, right?
Yes.
Then what will we have? Can we use the double angle formula for cosine?
We can.
Okay, we want sine over cosine, right?
Right.
So here we'll need to use the 1 minus 2 sine square pi over 8. So here 1 plus 2 cosine square pi over 8 minus 1. Correct like this?
Correct.
So for this, 1s and 1s can cancel. So 2 over 2, 1, right?
Yeah.
Sine square over cosine square, tangent square, right?
Correct.
So it will be like this. Am I right? Wait a second. this will also need to times. But actually it's not really the numerator also times, right? Okay, that's minus 1 ln 1 minus square root 2, right? Which is actually in a constant. Okay, let me just tell you. Here, this part, times the 1 minus square root 2. This part. Yes. Then remember, this is a minus 1 plus square root 2. So it's a minus what? 1 plus square root 2 times 1 minus square root 2 is? It's a negative 1, right? It's a negative 1.
Yes.
So yes, correct, it's a plus 1. Then after that, the numerator?
The numerator will be 10
Correct.
pi over 8.
Then plus your arbitrary constant. Remember, it must change? Yes, correct. Continue over here. After that, for this part, what do you think you can have? So this, we have this 1 minus square root 2, right?
Yes. So it will be thus.
Yes, correct. Because I need a negative, so it will go to the back with a negative. Yeah. Write it properly. Wait, here you need a negative, so it will come back, which is a 1 minus. Remember, 1 minus the tangent x over 2, tangent pi over 8. Yes? Yeah?
And remember thus.
Okay, this is when we have the
Faster.
So it's like this, right? Okay, yes, you can have it like that, right?
Yeah.
So is this method right?
Yes.
Okay, so what did you realize about this? We have different... Okay, actually this is just one substitution, right?
Then after that we
Sum
will
in.
have trigonometry.
Okay, first sum in, right?
Yes.
Sum in then. This is actually common denominator. And
Common.
then simplify.
Correct. After that,
After completing square.
completing square, then
Factorization.
yep. Partial
Partial fraction.
fraction. Integrate.
Integration.
After we integrate, we
Sub
sub
back.
back. Then
Reverse order, right?
yep.
But it's actually reciprocal because then we have the actual negative here. Then after that, what do we have?
After that, we would change the numerator to the tangent power over 8 and the denominator become like this.
Then we can have? Okay, we can.
Last, we will
also use this for it to replace this, right?
Yep. After that, the denominator change.
And last but not least, we use this tangent, right?
The tangent formula, which is also a trigonal identity.
Okay, well, so are you clear of these so far?
Yes.
Okay, so just to remember the three methods that we have used. What are the three methods?
The three methods is denominator rationalization, trigonal identity, trigonal substitution.
Yes, correct.
Last but not least, it's this method with a complex variable.
Yes, this method is the complex variables, which is method number?
Method number 4.
Okay, method number 4. Well, we have to change this into complex variables, but how? Well, we can change the sine and the cosine. Okay, are you sure that that's your answer?
Yes.
Okay, yes, it's correct. Like this, right?
Correct.
First we can common denominator, and then we can this. The denominator or the denominator goes to the numerator.
With first, we will a common denominator.
That's what I said. Like this, is it right?
Correct.
Okay, well, next for this, 2r can put in front, right?
Yes. And remember, we can take out the e to the power.
Well, we'll regroup.
Yes.
Like this, right?
Yes.
So for this part, can we both numerator and denominator times e to the power of ix?
Yes.
Like this, is it right?
Yes.
So right now for this part, can we factorize the 1 over I plus 1?
We can.
Then we can put this in 2, right?
Correct. Wait. What? Can you write your integral properly?
Okay, so right now we'll use one of the formula. Okay, well for this, here we have a 2 over I plus 1 first, right?
Yes.
Times the, like this, is it right?
Because the reciprocal from the 1 over.
Then we can use a, like this, is it right?
Yes, and we're going to, wait, before we use that formula.
Well, actually first we can simplify, rationalize.
Yes. And combine.
Well, actually down here will be a square root. I plus 1 times I minus 1, which is a,
Which is I square minus 1. So in that square root negative 2, which is square root 2i. Right?
yes. So this reciprocal, right? But remember both of these times I plus 1, am I right?
Yes. Because later we still need to reciprocal.
Okay, right now we can both of these rationalize. Can we?
We can.
Have you ever wondered why this is a 1 minus I?
I think I know why. The I.
What's wrong with the I? Okay, let me just tell you, both of these sides times the I, right?
Correct.
Here times I is actually a I minus 1, right?
Correct.
Well, at first it is I squared plus I, which is actually I minus 1. And here, don't forget about this extra negative.
Correct.
So you need to change those two, which becomes a 1 minus I. Is it all right?
Okay.
what can we have for this part? Okay, we have
We could have,
e to the power of ix. Can we change it?
yes.
Like this, right?
Yes.
Then after that, what can we have?
We could have,
We expand, right? And then after that, we group, right?
correct.
Like this, is it right?
Right.
So after that, we have this cosine and sine. Can we either change the cosine to a sine or the sine to a cosine? Can you write down what do we have? From this group, would you change the cosine or the sine? You'll change the cosine to a sine, right?
Yes.
Do you know how to continue this part? Yes, this is the first group. Then the second group. Second group is here also.
And that is a square root.
So for here, I'll change the sine to a cosine. Wait, where did you get the extra bracket here? Okay, so right now we need to use the
Sa.
yes. Like this, which is for the first part, and then the second part. Like this.
Yes.
So right now you can start with that. So there you have the 2 sine pi over 4 cosine. Remember the cosine there has a bracket because there's 2 terms inside. Yes. And And there you have the minus x. So there you have that plus I. Well, actually, because of this negative, so you can put it as a negative, okay? Here, this part you can put it as a negative. Because that for this, the cosine minus cosine, there's an actual negative. Yes. Wait, and your... Okay, yes. So that will be the sine pi over 4 sine, yeah, then over, what happens here? Okay, so there you have it. Then after that you can okay, so right now for this part, okay, so can we factorize? For this part, we will factorize as sine pi over 4x. Okay, so next is that you sub in these two formulas, right?
Yes. So actually here no need a bracket anymore.
Then the cosine. Don't forget the bracket because there's two terms for the cosine, right?
Yes.
And there's the minus x.
Yes, at first it's a 2x over 2, so simplify.
And your ending bracket.
Yes.
But remember, for the cosine minus cosine, it's actual negative here.
So here we'll have a negative.
Yes. Then you have the... Okay, so same, there's a sine pi over 4.
Yes.
Sine pi over 4 minus x. Over. Then continue behind. So sine pi over 4 is actually square root 2 over 2.
Yes, and simplify, 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 simplify. Right?
Yeah.
So now it's only left for one cosine and one sine. Like this, right?
C1. Okay, then you have, let me write it down. Okay, so next up, we'll have one of the formulas.
Yep.
Which will change the inverse tangent to a ln, right?
Yep.
Which is actually like this, right?
Okay.
So now you will have that in your working. So actually for that, remember yes, correct, the actual I over 2, the ln. And remember this is a z? This will be the z.
Yes.
Okay, well right now for this, you have this 1 minus the I bracket. Actually it's this thing, right?
Yes.
Then okay, so you have that and then denominator.
Yes, which is your plus.
Then, okay, so right now you already have this part, right? Am I right?
Yes. So here these two times together, negative 1, negative cancel. So 2.
That's the square root 2 over 2, right?
Yes.
Which first part already the same. And then you have the ln, which here is also the same, right?
Except for we need to find a way to change it into a tangent.
Well, for this part, do you straight away times it in?
No.
Yes,
Kidding.
times it in.
Yes.
Times it in. So there you minus the sine x over 4 minus x. Over
Wait. No, here's a plus because
negative, negative, negative.
okay, since here also have negative.
Then here what do we have?
Over
Remember, negative, negative. There you have the yes. Next, what will we have?
we will change the and before that we'll shift one side for the imaginary part and one side for the real number.
This part, for example, the cosine, we can change it into a sine, and the sine can be into a cosine, right? So
Yeah.
we'll use the half pi to minus the thing inside, which will have the pi over 4 plus x, which we can write it as x plus pi over 4, right?
Right. let other people see.
So we'll have like this, am I right?
Correct.
Then next we can have, okay, we can use the cosine to x and the sine to x, right?
Yeah.
So cosine to x, what can it be? Would you change it into sine something? Actually, it's the 1 minus 2 sine square x,
Yes.
right? Would you change it to that?
We can. Actually, numerator will change it into this denominator, still cosine, except a different way. Like this.
Okay, how about the sine to x?
Sine to x is,
Write it down. So there you will have the 2 sine x cosine x. After that we'll have this plus c, right?
yes.
Okay, so next what do we have?
You still have a 1.
So like this, there we can have the
Wait, here also.
Then after that for this, both the numerator and denominator, we can simplify the 2, right?
Yes.
And can we factorize one thing?
We can.
So here we have this minus here, right?
Yep. I. Yes. Same.
when the numerator times I for this part, it will be the same, right?
Correct.
So we can simplify that. And remember for this will be the tangent, right? Minus. Okay, write it down. The divide is actually a minus. So we can put that into the C.
So ln divide is equal to ln minus. Yes, you just need to change the C1 to a C. That is the
So it's like this?
answer. Okay,
Let's see, is it right? Okay, yes, it's correct.
yes, we didn't put C here because here if a C then same.
Okay, so right now for this. Can you see this? The complex variables. You know that it's a general way, right? A general
Yes.
method.
And it's a long method. Actually, we totally use 10 methods.
Okay, those 10 formula, right?
Yes. Even though we use more than 10 methods.
Okay, so first we have the sine x and cosine x changing into the complex variables form,
Yes.
right? Then common denominator, reciprocal.
Correct. After we done that, we regroup and take out the 2i.
Because that the 2i is a constant, right?
Yeah.
And then after that, the numerator denominator times e to the power of ix, put in the e to the power of ix, and factorize the 1 over I plus 1, right?
And put in the e to the power of ix.
Yes, that's what I said.
Change it to the tangent form.
The inverse tangent, right?
Yep.
Then after that, we have the, from this to this step, simplify, and then we can expand, right?
Correct the expand.
Well, here is rationalize, reciprocal, expand,
Expand again.
right?
Yeah.
For this, we'll just change this into another form, right?
Correct.
So after we change it here, rationalization, simplify, right?
Correct.
Then we have the, okay, so here is also rationalization. Okay, change the e to the power of ix using the Euler's formula, right?
Correct.
So we use the Euler's formula, expand,
After we expand,
we change the cosine and the sine, right?
then we...
Okay, after we change the cosine and the sine, we use the sum and difference of two trigonometric functions, right? That formula. After that, we have this, correct?
Correct.
From this step to here, what happens? You know what happens?
What?
Okay, actually, we'll just put in the sine pi over 4 as square root over 2. And then we'll get this part. Now we use another formula, which is the inverse tangent z is equal to I over 2.
2.
I over 2 what?
It will be I over 2.
Okay, let me just tell you, so I over 2 ln
1 minus z.
I
I z over 1 plus zi. It's okay.
I z. We always say that. I z.
Okay.
Then what do we have? So here we
After
expand, right?
expand.
After we expand, what happens? We change the cosine and sine again, right? Right?
Yep.
Okay, what happens? We have is this the double angle formula? Is it the double angle?
Correct.
Which we use the cosine to x and the sine to x, right?
Yes.
It can be called a double angle or the half angle. Then what do we have? Okay, after that we can cancel these ones. Am I right?
Using the double angle.
When we have the double angle, there's this ones, right?
Then we cancel.
Then what do we have?
Then we take out sine.
Factorize, right?
Yes.
Factorize, and then both the numerator and denominator times I. And sometimes and simplify. Here still have the I. Then we use the division inside the ln is the ln minus the ln.
Ln.
Okay, and that's how we get our answer, and all these methods are correct. So are you clear for this?
Yes.
Okay, so can we end our lesson here, and do you have anything to say?
If you like our video, don't forget to subscribe to our channel.
Okay. Thank you for your watching.